All right, so now we're on to 1-6. I forget how many sections there are in this chapter. I think it's 8, and I think one of them I may skip, so this may be the next to last section of this chapter, okay? I can't remember exactly. I don't have the book open, but actually I do have it open, but I don't know. Let's see. 1-7. Oh, yeah, we're going to skip 1-8, okay? It's something that I've taught before, but I just don't think we're going to skip 1-8, yeah. All right, so anyway, let's do today. Let's do 1-6. So the first word of the day, all right, we always do definitions, okay, especially the first chapter. We have tons of definitions. And so here we have another one, and that would be a circle. Like, well, that's pretty easy. I've seen circles before. I know all about circles. Well, we have, I believe, if I remember right, we have a whole entire chapter just on circles. A whole chapter of it, right? Forget what chapter it is, but I believe we have a whole chapter on circles. So this is only going to scratch the surface today on circles. But we do need to start with definition. And I'll tell you what, I'm going to type it out. How about that? Oh my, what's all that mess? I think I'm going to type it out. Actually, what's the question?
So do we ever turn in that homework from...
We've turned in everything.
I never turned it in.
Well, turn it in then.
Is it going to be late?
Yep. All right, so here we go. Let's write this down. Oops. I'm going to go do this. All right, let's do this. Let's write this down. I'm not going to write down every single definition we're going to do today, but I will write this one down because I think this is pretty important. All right, so you write it down too. It's the set of all points. Now, we don't stop there because it's not every single point in the world. Okay, in a plane. All right, so we narrowed it down a little bit. But that would just be all the points in a plane. But here is the part about the circle. Is a given distance from a given point. That may not make any sense to you at all. And you're like, how in the world is that thing a circle? And we call that thing the given point. Oops, forgot to write point in there. From the given point. Oh, if I could write. Come on. There we go. And we call that given point the center. It's the center of the circle. We'll talk about that just in a second. So, what if I had this? Yes?
We're not going to go over like circumference and pi.
We are. Yep. All right, so let's just worry about the definition right now, okay? So it says the set of all points in a plane give a given distance from a given point. So let's say this is our given point right here. All right? So it says a set of all points, a given distance. All right? So from this point. So let's start with this point. There's a given distance right there, isn't it? Okay, that's a certain distance. Okay? Does that make a circle? No, it says all the points from a given point right here. Okay, that's a certain distance. So this distance right here, let's see if I can do this. Might not be the fastest, but, and then let's do this. And then let's move it so this is the same distance, wouldn't you agree? And it's the same distance from that point right there. If I kept on doing this, oops, come on. There we go. What if I did this? And what if I did this? And what if I kept doing this all day long? What would I eventually get? I would get a circle, wouldn't I? Would you agree with that? All right, so this is a given distance, all these. I could keep doing this, keep doing this, keep doing this. And if I did this 100 times, 1,000 times, 1,000,000 times, what would it look like eventually? It would look like a circle.
Would you have to put the arrows on it or no?
No, because it stops. Remember, it's a given distance. If it had an arrow on it, it wouldn't just be a given distance. It would keep going forever, right? So these are basically line what? If it has a start, right, it's a line segment because it has a starting point, it has an ending point, all right? You with me on this part with the circle? Okay. So I'm not going to do it 1,000,000 times. I'm just going to draw a circle. So let's see. I know I can get a circle right here. And see that dot in the middle? What do we call that dot in the middle? Call that the center of the circle, okay? So this dot right here is the center of a circle, and it's a point. How do we label a point? Just had a quiz on it. Use a what? Capital letter, okay? I use the letter C on this one, okay? And then let's draw one of those given distances, okay? Just one right now. It could go, it's got to start at the center. Oops. It's got to start at the center, and it can go anywhere as long as it hits the end of the circle, okay? With me on that? All right, so the curvy thing, that's the circle, okay? And this is the given distance, right, from the point, or from the center point up to here. And so, yeah, you've done this before. So, Ben, what do we call this thing? Right. And it goes to a certain point, so I'll put a point right there, and we give this a name. Let's put this in a different color. We give this a name, and we call it the radius of the circle. Okay? It's supposed to be an S. That's the radius of the circle. It's very important, okay? Somebody asked about circumference and all that kind of stuff. We are going to have an equation today. I don't know if it's today. Let's see. We may not get to it. That may not be till tomorrow. All right, but we will in this lesson, right, talk about something. And pi, right, exactly. Pi is part of our circle equations. It is. But it doesn't stop there, does it? It keeps on going. But anyway, we're not going to talk about that right now. That's in the, listen. This is, that's a little bit later in the lesson, but we're going to do some other stuff with this right now, okay? Now, if we were going to name the radius, if I asked you, I give you a quiz, right? And I give you a circle, and I give some letters, I give the center, and then I give a point where that radius hits the circle, and I said to name the radius of this circle. What would you name it? Remember, it's a what kind of thing? It's not a line, it's not a ray, it's a line segment. So how are you going to name this radius? What would we do? Okay, CB, right. Now, and put the line segment over top of it, because it's not indicating how long it is, right? Remember, if it didn't have a line, it would mean the length of the segment. I'm just naming the segment, so we got to put line segment over top of it. Now, I could also call it line segment BC. That would be fine. But most of the time, you don't have to do this. Most of the time, we start with the center of the circle and go out here, okay? You don't have to. We could have called it BC, line segment BC, and it would have been fine, all right? But a lot of people would start at the center, because that's kind of like the really important part about this circle is the center, okay? With me on that? We also have a notation for the circle, and we can name this circle. We don't name this circle line segment CB. That's not the name of the circle. What did I just say was the really important part of the circle? The what? The center of the circle. So that's how we name the circle. So we don't write the word circle, and then we would say C is how we would say it. We would say it circle C, but we write it like this. We write a circle, but then we put a dot in the middle. That's the notation for circle, okay? We had a notation for line. We had a notation for ray, for line segment, for angle. We've had a lot of notations, right? This is the notation for circle. And again, how do I name the circle? I name it by its center, and this is circle C. So that's how you would say it. Sam, in the trash. I warned you. In the trash now. All right, what was the question? Somebody said something over here. Yeah, kind of like that, okay? So that's how we name the circle. Pretty easy? Yeah, that's simple. All right, let's move on. Yes, sir. Yes. There's tissues right there. All right, let's do another word. Let's do the picture first. Now, I should have figured this out. I know there's a way, but I can't figure out how to do it. Maybe if I go up there, I don't know. But I can do something like that, okay? And I should be able to change how many sides there are on it, but I just don't have enough time to sit there and look. I don't know, maybe is transform? No. Let's not talk while I'm trying to do something. It's not your time to talk. Just sit and watch and listen, okay? Let's see, shape properties. Oh, there we go. I figured it out. Right up here at shape. So how many sides does this thing have right here? 1, 2, 3, 4, 5, 6. So I could change it to 5 sides like that. Pretty cool, huh? All right, so that's kind of nice. But And at this point, I don't really care how many sides I make this. And I think I can rotate it as well. Let's see. Yep, I can rotate it. We'll make it kind of nice like this. How many sides does this thing have now? It's got 5. What do we know that's out there in the world that was really famous? It's called the Pentagon. Okay, do you know the Pentagon? Yeah, it's like the hub of the U.S. defense systems and all that kind of thing. All right, it's in Washington D.C. And what really famous event, a tragic event, but a famous event happened with the Pentagon? Anthony?
Wasn't there like a bomb?
Wasn't a bomb. It was a plane, right, at 9/11, right, in 01. So how many years ago was that? 21 years ago? Yeah, we just, all right. This is not your time, it's my time. Let's listen. Jimmy? Sam? So in 2011, right, that was part of the 3 big tragedies, right? There was New York, then there was that plane that crashed out in Pennsylvania, some field that was probably heading towards Washington, D.C., and people think they were heading towards the Capitol or the White House. So actually, there were some heroes on that plane that took that plane down so it wouldn't go into to make it even more tragic. So, but that's ancient history to you guys. I lived it. I remember it like it was yesterday. But we didn't talk about it on 9/11. We probably should have said something about it. But anyway, this is the Pentagon. That's what it looks like. So if you see, you could Google it. Get an aerial view of the Pentagon, somebody straight up and down, and it looks just like this. But there's like another part of so the building is basically 5 big, huge hallways is basically what it is. I've never been inside it. I've driven by it on the highway, and I've seen it off the highway in D.C., but like it comes like this, and this, and it's got this big open area in the middle. I've never been in it, but that's what it looks like basically. So that's a pentagon. So in geometry, though, it is a pentagon. We're going to talk about that in just a minute, but in general, it doesn't matter how many sides you have. If you have a closed figure, which means all the line segments will close it all in. There's no gaps in it, okay? And they talk a little bit, they do some definitions about closed and all that kind of stuff, and concave and convex. I'm not worried about that too much. I will probably talk about concave and convex a little bit, but this is a closed figure, okay? If it's a closed figure with sides, they're not curved. Each side is a line segment. You see that? Nothing's curved on it. We can call that a polygon. Have you ever heard that word before? Yes. Okay, good. All right, so we can call that a polygon. Again, this is a specific polygon. I could change this to 4 sides, 5 sides. I could make it 3. Can you have a polygon with 2 sides? No, because it wouldn't be what? It wouldn't be closed. There's no way you could close it in, right? If I put 2 line segments end to end, is there any way I could close them up? No, the only way is if everybody watching? So watch. You got a line segment here, line segment here. The only way I could probably close them up if they did this, but then there wouldn't be any gap in there, would it? Those 2 line segments would just make up 1 line segment. Would you agree? Yeah. So you can't have one with 2, but you can have one with 3. Do we know the name of that? Triangle. Yeah, we're going to talk about that in just a second, but let's do a little bit more with this. Each of these line segments, we give it a name, and we call it a side. Okay, remember, it's a line segment, but we call it the side of the polygon. All right? And we talked about this. Look at these 2 line segments. What do they form? We talked about this before in that last section. What's this thing right here? Well, it's an angle, right. It is obtuse, you're right. And actually, later on, I'm not sure, not in this lesson, but later on, I'm just going to give you a polygon, and you're going to figure out what the degree measure is of each of these angles without giving you any information at all except that this is a polygon. Okay? It'll be later on. But thanks for your enthusiasm. I do appreciate it. Most people say, oh, I don't care. But at least you asked, how do we do it? But we will learn that eventually. So this is an angle, and what is that point called on an angle where those 2 rays come together? What do we call that? And we call it the vertex. So guess what we call it on a polygon? A vertex. Okay. You did bring something up. I didn't talk about this. If you have more than 1 vertex, which this does, how many, I'm going to say it wrong right now, okay? How many vertexes, that's not the right way to say it, but how many vertexes does this particular polygon have? It's got 5 of them. So we say it has 5, and Gavin's saying it a bunch of times. Vertices, okay? So that's the plural for vertex, okay? So if we have more than one vertex, if we have more than one vertex, we call it vertices. All right, that's the plural. All right, you with me on that? All right, enough of that. Let's see what else I've got on here. Oh, let's talk about this specifically. Now, the way that I drew this on this computer program, what do you think is true about all these sides right here? They're equal, yeah? And we have a special name for that, all right? So we could have a polygon that doesn't look like all the sides are equal, okay? It doesn't have to have all the sides equal for it to be a polygon. You could have one side way shorter than the other. But as long as the line segments all come together and they don't have any gaps in it or anything like that, it's still called a polygon, okay? But if we have a polygon when all the sides are equal to each other like that, we call that an equilateral polygon. Is that what you're going to say? Did you look in the book? You already knew it? Good. That's good, though. All right, so we call this an equilateral polygon. Now, I'm not going to write it down, but you should. An equilateral polygon, all the sides are equal. So write that down, okay, for equilateral polygon. Because lateral means side. Any basketball players in here? There's this drill that you do, a defense drill, where you get down like this, right? And your coach blows a whistle, or they move the ball this way or this way. Even in football, they do that drill a lot, right? And what do? They call that the lateral drill. Why? Because you're moving what to what? Side to side, okay? So the lateral basically means what? The sides. Equa, all right? What word do you see in there? It's not exactly equal, right? So equal sides. Pretty simple to understand. This polygon right here also, see that angle that's made right there? Guess what's true about all these angles? They're all equal as well. Not every polygon has equal sides. Not every polygon has equal angles. This particular one that I drew with this computer program has both. It's got equal sides and it has equal angles. But let's talk about the angle part first. So we have another word for that. So we also call it equa, but not lateral this time. We're talking about the angles. So what would we call it? Equa angular. But that's a good guess. Okay. All right, so we call this an equiangular polygon. That means all the angles are equal, okay? Now, you can have a polygon where all the angles are equal, but the sides aren't necessarily equal, okay? You could have a polygon where all the sides are equal, but not necessarily the angles, okay? But if you have both, if both of these things are true, if you have equilateral and equiangular in the same polygon, we call that a regular polygon. Seems like a boring name to call it, right? Because it's kind of a cool polygon because all the sides are equal, all the angles are equal. The Pentagon in Washington, D.C. is it's a regular polygon. So if you don't try this, but if you go to the Pentagon, if you have like a protractor or something like that, right? You go to each of the corners and you can measure the angle, and they're all going to be the same, all right? And that's a regular polygon. Yeah, people work in there. So you have to have pass and stuff like that. They'll check you. Yeah, you can't just walk in. You could probably do a tour, but again, they'll probably, wand you, to make sure you don't have anything on you and all that kind of stuff All right. So let's talk about some different types of polygons. We already mentioned one. This one, we already said what kind of polygon it was. It's regular, but as far as how many sides does it have? How many sides does this one have? 5, and we call it a what? Pentagon. So let's make a little list of some real famous types of polygons. So we're going to classify, is what the book says. Okay, we are going to classify polygons by the number of sides, okay? We're going to classify polygons. So I'm going to make one list for the number of sides, and then I'm going to tell you what the name is. All right. So what's the smallest number of sides we can have that makes up a polygon? 3. And of course, what do we call that? You know that one. Right, we call it a triangle. And most of these you're going to know already, okay? This shouldn't be brand new to you. There's going to be a few in there that you're like, oh, I've never heard that before. But most of them, I bet you'll have heard before. It can be equal sides or non-equal sides. We said that earlier. Okay, I just said a polygon doesn't have to be all equal sides. Okay, you can have different, as long as it's closed. Okay, as long as the sides are line segments and they're closed, right? There's no gap in it, then it can be a polygon. But these are just if you have 3 sides, you could have a triangle. Okay, what if you have 4 sides? What do we call that? You'd think we would call it a square. You'd think we'd call it a rectangle. Now, a square and a rectangle are kind of like a subset of what we're going to talk about right now. Okay, and Gavin got the first part right. It's quad. Okay, it's quadrilateral. Now, is a square a quadrilateral? Yeah, why? It's got 4 sides. Is a rectangle a quadrilateral? Yeah. But tell me something about a square, because we talked about it already. Just envision in your mind a square. A square is also something else that we've already talked about. What's true about all the sides? All the sides are equal. What about all the angles in a rectangle or a square? I'm sorry, a square. They're all the same. So a square is a what? It's a regular polygon, isn't it? Okay, you with me on that? Okay. I'm getting ahead of myself, but I'm going to do it anyway. It's too fun. I don't know how fun it is, but what about a square and a rectangle? Is a square a rectangle? Yes, a square is a rectangle. Is every rectangle a square? No, it's not, okay? We'll talk about that later. Let's do this. We've already talked about this one. Right. Okay, what is a 5-sided figure? We've already discussed it, but here it is written down. Now, we're starting to get into some that might be a little bit weirder. You've probably heard of this one. If you have 6 sides, right, we call that a hexagon. Hexagon. You'll see a lot of hexagons. 7 you don't see too often, so it's a word that we don't really hear. In fact, I used to teach out of a book, I used to teach out of a book that went through all these names, and it gave a 7-sided figure. They called it a 7gon. They didn't even give it a name. But I've heard this a lot before in other books, so we'll call it this. They call this a heptagon. Heptagon.
Are they going to call it heptagon?
They call it a heptagon. All right, let's keep going. You probably see one of these every single day, an octagon. That's right, a stop sign. A stop sign is an octagon, all right? And it's a regular octagon. All the sides are equal, all the angles are equal. So if you happen to have a protractor and you stop by a stop sign, jump out of the car real quick, do a little measurement, and you're going to find that all the angles of a stop sign are equal to each other. And if you have a ruler, go up there and measure the sides. I actually had a job that I worked with stop signs all the time. So I had a job all through college. It was my summer job. As soon as I'd finish college, I'd start this job, and I worked for DELDOT. You know what DELDOT is? Yeah. DOT is Department of Transportation. You ever see the orange trucks, all drive by, and they fix a lot of things? But my job was to fix the sign. So if a stop sign got knocked down, or a street sign got knocked down, or a yield sign, or anything like that, people would always call in, and we'd have these slips of paper, and we'd go out every day and fix stop signs and everything else. So I was around stop signs a lot in my life. So there you go. Now, 9 is a little weird. It's probably one that you're not too familiar with. They call that a nonagon. Okay? Nonagon. It's kind of weird. 10's pretty, Gavin, stop. If I got to say your name again, I'm gonna write you up. Okay? It's too much today. You got to learn when to stop. There's times when you can do a little chatter, but then it's got to end. You just keep going. You never stop. Okay? So let's stop. So let's take a look at 10. 10 sides. And this is something like 10 years. Every 10 years we call a what? A decade. All right? So deca is a prefix for what? For 10. So guess what a 10-sided figure is called? It's called a decagon. Okay, it's a decagon. Yeah, deca is a prefix for 10. Now these, to tell you the truth, I never knew what 11-sided figure, because my books that I've taught out of before always stopped at 10, all right? But this one goes to 12, all right? So we're going to do 12. So they call this one a hengagon. Decagon. Never heard of that before until this book. So I don't know if that's really familiar. You could always Google it. But Decagon, that's what they call an 11-sided figure. I doubt we'll really deal with a 11-sided figure that often. 12-sided figure you see a little bit. We call this a dodecagon. Dodecagon. Now, we're not going to keep going forever and ever. We stop right there with the special names, okay? But now, if you have a polygon with n number of sides, n represents what? Any number of sides, okay? So any number of sides. We just call it, now we don't call it an n-gon. So if it had 15 sides, what would you call it? A 15-gon, okay? I probably would never say that. I would just say it's a polygon with 15 sides. That's probably how I would say it. But they say that if it's got 15 sides, call it a 15-gon or whatever, all right? All right, with me on that? All right. I don't know who came up with that. All right, turn your books to page 33. There's an example in there. On the top of 33, there's example 3. I'm not even going to try to draw it because we're running out of time. But let's just look at it. Do you see the top of 33? All right, let's take a look at that. I will draw a little bit. I don't think I'm going to draw the whole entire thing. But I'll draw something like this. I may not do all the sides. All right, everybody look up here. I'm not drawing that exact figure on A. See example 3A. I'm not drawing that exact figure. I'm drawing another one. So, yeah, it's good right there. I guess I should have just tried to draw that figure, but there we go. All right, let me show you this. Listen. Let's take a look at this. Is this a polygon? Yeah, everything's closed. All the endpoints hit each other at the ends, right? Do you see that? All the segments hit each other at the endpoints. That makes a polygon. And it's closed. But there's something a little different about this, and I just want to say this word. I mentioned it once before, and I said we'd talk about it a little bit later. Here's the time where we talk about it. If I was to extend each of these sides, okay, so let's start here and extend that side right there, and then let's extend that side right there. Do you see that? Let's do it again to this one. I'm not going to do this to every single one. And let's see. That's good right there. Do you see how these all go outside? When I extend it, this line goes outside of the polygon and this part goes outside the polygon. Same with this, same with this. But now, watch this. What if I start here and extend this one? And then this one like that. Actually, let's extend this all the way through. Now, do you see the red? On this one right here, all the red was either on the line or it goes outside the polygon. You with me on that? Same with this. But what about this one right here? This one actually goes inside of the polygon. So if you were to extend all the sides, if you have one of the sides that actually goes through the polygon right here, we give that we give it a name. We call it a concave polygon. All right? So this would be concave because it's like this. When you think of something caving in, you think of it like just kind of coming in on itself, don't you? So watch this. What if you had two sides? Sam, I'm here. I'm not back there. Sam Taylor, just so I can let everybody know who it is. So just in case I got to say something. All right. So everybody look up here. So let's say you had this. If you have sides that do this, that would be convex. But watch, as it goes like this, it starts caving in, doesn't it? You see that? And then it points in towards the polygon. So these two sides right here, oops, try this end. these two sides right here, this one and this one, right? If I was to extend that and then extend that, that one also goes through, it goes inside the polygon, doesn't it? Okay, see all this stuff right here? That's in the polygon. All this stuff right here, whoops, all that in there, that's in the polygon. So if you have that, then it's called a concave polygon. All right, that's the one thing that I wanted to talk about. What about the first figure that we did? Is that concave or convex? Convex, because all the sides, if I extended them, all the sides would extend outside of the polygon. Does that make sense? Okay, so this would be considered convex because if I extended this side and this side, none of these sides would actually go inside of this polygon. But on this one, see where this kind of caved in here and here? If I extended the side, it will go in. So we call that a concave polygon. Later on, we'll deal with this a little bit more. For right now, it's not that big of a deal, but they could ask you a question on the homework, okay? They could say, is this a concave or convex polygon? And that's how you could figure it out. We good with that? All right. Let's see. I think we're going to stop there. Oh no, let's do this before we stop. Let me make sure I got everything. Yeah, we got a couple minutes. I can do this real quick. Let's go back up to this one so I don't have to redraw something. Let's go back up to this polygon right here. And what if I did this? What if I connected one vertex to another? Now, we call them non-consecutive vertices. All right, there's our vertices. If I start here, I'm not connecting from here to here because that would be consecutive. Consecutive means one after another, okay? So I'm not connecting from here to here. I'm not connecting from here to here. I'm connecting to the non-consecutive. And we're going to come, this is going to be important later on, okay? But we're just defining it right now. If I go from here, where could I go? I could go to there. You see it? I could go to where else? Right there. Okay. And we call these. And we call these diagonals. All right. So if I go from one vertex to another vertex that's not right next door to it, I call that a diagonal. So these would be diagonals. And we're going to deal with this later on again. Okay. Remember I said something about you'll be able to figure out how many angles are in here? This is going to help us figure that out later on. Okay. Not right now though. All right. Also, one more thing and we'll be finished, I promise. How do we name a polygon? Well, we name it by its vertices, okay? So we don't really, we don't have a symbol for it. We don't have any kind of notation. We just write the word polygon, and then you would write it. Now watch. It doesn't matter which one you start with. It does not matter. You don't have to start with the first letter of the alphabet, okay? It does not matter. But let's just, for the fun of it, start with this one, okay? And it does not matter what order you go, but you got to go consecutively. So I could call this, there's a bunch of things I could call this, okay? But I would call this A, what do you think? If I got to go consecutive, let's go this way. I call it A, B, C, D, E. So A, B, C, D, and E. All right? So that's what I would call it. Now, your homework. Now, there possibly could be some homework problems that we've not gone over yet, but try to do as much as you possibly can, okay? So I'll just put it right here. Oops. So I gave you the lesson plans before, but it's 1-6, so it's section 1-6A, and it's pages 35 and 36. This is on your lesson plan. I gave it to you on Monday, but this is for the people on YouTube if you didn't get a lesson plan. 13 to 20 and 31 to 43. Now, there may be some on here, I can't remember every single problem, but there may be some on here that we haven't covered yet today. But try to do as many of these as you can, okay? Try to do as many as you can, and then we'll finish it up tomorrow. There it is.